Arc openings may very well be one of the generally captivating and puzzling peculiarities in the universe. They are monstrous monsters regarding power, yet at a similar time practically undetectable to us. A dark opening weighing maybe 2 to 4 multiple times the mass of the Sun is a great representation, as a result of the examination that was placed into them over the last years. We've gone from knowing literally nothing about them to getting to find out increasingly more very close. Furthermore, while things have simply gotten more insane, Kaku recently reported that we at long last got to check what's inside a dark opening. This new data carries light to the subtleties the universe of science could have missed from the start. Join us as we dig further into dark openings and disclose what's inside. Space is enormous and awful. Before we dive into the subtleties of what Kaku found, we need to discuss the firsts. Despite the fact that a large portion of us have some thought of what dark openings are, there are still a few holes in the right data. You see, in 1916, Albert Einstein distributed his hypothesis of general relativity, which anticipated the presence of dark openings. Around then, the idea of dark openings was absolutely hypothetical. It required an additional 50 years for the logical community to track down proof that dark openings really exist. This occurred in the 1960s when they were considering the Cygnus star grouping and saw a strangely dazzling blue star producing X-beams. This star was definitely not a stale item. However, it was circling around a Goliath dark something. Upon additional examination, it was observed that the X-beams weren't simply moving around all alone. However, they were being sucked into the dark thing they were circling. Consequently, the name dark opening. This revelation was huge in light of the fact that it gave evidence that dark openings as a matter of fact exist, and that they were not simply a fantasy of Albert Einstein's wild creative mind. While that was extraordinary, it too really intended that there was this unbelievable substance in space that we critically had to be aware of. Specialists overall around the world got to work. This dark opening was named Cygnus X1, and it is situated in the heavenly body Cygnus, around 6,000 light-years from Earth. It was no little disclosure. It's multiple times more brilliant than the Sun and extraordinarily thick, which makes it have serious areas of strength for a pull. The gravitational force is so areas of strength for that not even light can get away from it. This is the reason it is known as a dark opening. The idea of a dark opening is both captivating, and it is to unnerve locale of room where gravity is so solid that nothing, not even light, would be able to circumvent. Whatever gets excessively near a dark opening won't be maneuvered into it ever to be seen again. However, that part of peril makes it significantly more important to learn all that there is to be aware of them. Was this it? Or were we just starting? The response turned out to be the last option. After the revelation of Cygnus X1, researchers began to look for other dark openings. They found that there might be near more than 100 million dark openings in the smooth way alone. But since they are so staggeringly difficult to identify, we still try not to have a precise number. In any case, from the vibes of it, there are a few million dark openings in the smooth way and our very system, which is what makes them considerably more vital to study. So we should separate it. The primary concern with dark openings is continuously going to be gravity. Their gravitational force is so extreme that anything that enters it packs down cosmically until it turns into a peculiarity. In less difficult terms, dark openings resemble astronomical vacuum cleaners that suck everything in. One of the most alarming parts about the exploration that has gone into dark openings is the reality that if somebody somehow managed to fall into one, they would quit wasting time that they become a solitary line. This cycle would happen gradually, and the individual would pass on before the last structure in reality sets in. So we should simply say that nobody ought to step into one, except for they're everywhere. So might we at any point truly be in peril? Regardless of the way that the nearest dark opening to Earth is 500 to 1,000 light-years away, it's actually close enough to raise questions and worries. In 2021, researchers had the option to deliver the first clear photo of a dark opening, explicitly the M87 dark opening. This dark opening was shot a few evenings in succession, and with each photo, the scientists assembled to an ever-increasing extent proof about it. They needed to fasten the individual photographs together to make something that filled every one of the holes. This way, they had the option to sort out that there are 3 layers to a dark opening. It's not only one single expanding opening of nothingness, as many individuals accept. Things are significantly more convoluted than that. To try and get to the nothingness part of a dark opening, you need to make it through the initial 2 layers. The first layer is known as the occasion skyline, which is the final turning point. Once you pass the occasion skyline, there's no turning back, and you will be sucked into the dark opening. It just deteriorates from that point on out. The subsequent layer is the photon circle, which is the locale where light circles the dark opening. Any light that enters this district will be caught and cannot get away from the dark opening's gravitational force. At long last, we come to the third layer, which is the peculiarity. This is where all that enters the dark opening gets packed down cosmically until it turns into a peculiarity. The peculiarity is a point in spacetime where the laws of material science, as we probably are aware of them, separate, and we just can't anticipate what occurs next. At the peculiarity, the thickness is limitless, and the laws of material science, as we probably are aware of them, fail to exist. Now what makes all of this boundlessly more terrible is the way that each and every dark opening you study will be totally not the same as the last. Certain they really do tend to follow a similar 3-layer idea, yet the manner in which they capability could be immeasurably unique. Now, if this were anything more, all we really want to do is jump back on those telescopes and just concentrate on the main pressing issue exhaustively. However, with dark openings, you can't actually do that. Researchers can concentrate on dark openings in a roundabout way by noticing the radiation they transmit and the gas and residue that encompasses them. Sending a test like the Explorer inside a dark opening isn't conceivable because anything that enters the occasion skyline is pulled towards the peculiarity, where it is compacted to an infinitely little point. So you can't precisely squander billions of dollars just to get an impression each time, in light of the fact that the second the test draws near enough, it'll simply smash into nothingness. Due to that obvious issue, researchers are left with no COIC. What makes all of this boundlessly more terrible is the way that each and every dark opening you study will be totally not the same as the last. Certain they really do tend to follow a similar 3-layer idea, yet the manner in which they capability could be immeasurably unique. Now, if this were anything more, all we really want to do is jump back on those telescopes and just concentrate on the main pressing issue exhaustively. However, with dark openings, you can't actually do that. Researchers can concentrate on dark openings in a roundabout way by noticing the radiation they transmit and the gas and residue that encompasses them. Sending a test like the Explorer inside a dark opening isn't conceivable because anything that enters the occasion skyline is pulled towards the peculiarity, where it is compacted to an infinitely little point. So you can't precisely squander billions of dollars just to get an impression each time, in light of the fact that the second the test draws near enough, it'll simply smash into nothingness. Due to that obvious issue, researchers are left with no choice except for to study these objects in a 2-layered manner, even however they are 3-layered peculiarities in actuality. To make matters considerably seriously testing, there are likewise the 2 issues of each and every dark opening being extraordinary and the laws of physical science, as we realize them, separating when we attempt to investigate within. This implies that the conventional strategies for logical request don't actually apply to the review of dark openings. That doesn't actually intend that the scientists haven't been occupied. There are bunches of various hypotheses and clarifications of dark openings, and with every one, things get to an ever-increasing extent interesting. One of the most convincing hypotheses about the arrangement of dark openings is that they are made from imploding stars. When a star debilitates all its fuel, it can never again deliver enough energy to balance the power of gravity that is continually pulling internal. Accordingly, the star begins to break down in on itself, decreasing and becoming denser. In the event that the star is adequately monstrous, this interaction can go on until it turns into a peculiarity. To comprehend the nature of dark openings inside and out, NASA researchers directed their concentration toward the center of the cosmic system. M87 space experts noticed a really strong whirlpool of very hot hydrogen gas that was turning at an astounding pace of 1.2 million miles per hour. The sheer power of the turning plate of gas ought to have caused it to fly separated in all fiercely bearings. Yet it didn't. Researchers found that there must be a huge mass assembled at the focal point of the world to keep this from occurring. This gigantic article weighed as much as 2 to 3 billion suns and must be a dark opening. However, that is not by any means the only hypothesis where dark openings turn. In 1963, the New Zealand mathematician Royer utilized Einstein's conditions of gravity to give the best depiction of a turning dark opening. They showed that a turning dark opening wouldn't implode into a point, as recently suspected, however into a ring of fire or a slight circle. The circle would turn so quickly that radiating powers would keep it from falling. This turning circle of issue is known as the aerosphere, and it is the district encompassing the dark opening where the laws of physical science begin to separate. However, the most fascinating component of Coureur's arrangement was that it anticipated the presence of an Einstein-Rosen extension, otherwise called a wormhole. This hypothetical passage through spacetime could associate two separate districts of the universe or even two equal universes. The thought is that assuming one were to fall into a dark opening, rather than being squashed to insensibility, one would be sucked down a passage through the ring of discharge and shot out a white. He text explores the fascinating yet mysterious nature of black holes, which are regions in space with gravitational forces so strong that nothing, not even light, can escape them. It discusses the historical context, beginning with Einstein's theory of general relativity in 1916, which predicted their existence. The first evidence of black holes came in the 1960s with the discovery of Cygnus X1, a binary star system where matter was being sucked into a black hole. The text outlines the structure of black holes, describing three layers: the event horizon, the photon sphere, and the singularity. The event horizon is the point of no return, the photon sphere is where light can orbit the black hole, and the singularity is a point of infinite density where the laws of physics as we know them break down. It also discusses the ongoing research into black holes, including the concept of wormholes, which could theoretically connect different regions of spacetime. The text mentions that while wormholes are a part of theoretical physics, their instability and the challenges of navigating them remain significant hurdles. The piece concludes with a discussion on superstring theory, which attempts to unify gravity and quantum mechanics, suggesting that particles are tiny vibrating strings in multiple dimensions beyond our four-dimensional experience of spacetime.